Okay, hello everyone, it's me again. Today we will tackle the problem called rejection allowance problem. So in a simpler term, it's just low volume production with random rejection. So why do we need this kind of problem? I believe you guys still remember this formula from the previous video about calculating the production requirement, calculating the input and the output. You remember that? So these formulas are fine, but they can only be used for high volume production. Because in high volume production, we can use the average value. But if we are operating in a low volume production environment, these two formula are not suitable at all. So let's imagine you run a factory, which is nhà máy luyện kim in Vietnamese, and you only produce small batches of custom design products because these products are customs, right? So you only produce them in a very small amount. And these products in foundry factory, they are called castings. Okay. And here's the catch. This is the problem. You only have one chance to produce the required number of casting, maybe because the production is expensive or the deadline is very urgent or something else. So in this case, you need to consider the probability of producing a good casting. So no effects. So you need to know, oh, if I produce this number of casting, what is the probability that I receive a good casting? Okay. The ultimate goal here is to decide how many casting you will produce, and you have already considered the probability of defective castings showing up in your production process. So here are some of the consideration. So you need to answer two questions. Uh, how much are the revenue and the cost to produce a good casting and a bad casting? Okay. And the second question is, what is the probability distribution for the number of good casting resulting from a production lot? And after you have answered these two questions, um, you can achieve one of these two goals. So you want to know the answer to this question so that you can maximize the expected profit, or you achieve a desired confidence level of not producing fewer good casting than needed. In simpler words, you want to be sure that you will produce enough number of good casting. Okay. So the definition of the rejection allowance problems is one, you determine the number of additional unit to allow when you are scheduling for low volume production, and rejects randomly occur. When you have these three conditions, you have a problem called the reject allowance problem. Okay. And here are all of the parameters of this problem. So here, um, I think I only need to explain this formula. So profit will equal to revenue subtract by the cost, right? Profit, revenue subtract cost is very straightforward. And how do you calculate the expected profit? You just take the profit for each scenario and you multiply by the probability of each scenario, and then you sum of them together. Okay, so now let me show you through an example. So here is the problem I want to show you. The example. I'm sorry. So in this case, you are still a foundry factory and you receive an order of 20 order. Your customer want you to produce 20 casting for them. And the production cost for you is here. Um, $1,100 for each unit produced. And if you cannot sell a product, maybe it's surplus or defective products, you or for some other reason that you can't sell the casting to your customer, you can recycle it with the value of $200. And here is the catch. The customer, they only accept 20 good casting. That's it. No more, no less. If you produce less than this number, they don't buy anything at all. So if you can only produce like 19 good casting, screw you. You are done. They don't buy anything. They only buy exactly at 20 good casting. So what if you produce more than 20, for example, 20 good casting, 21 good casting, they only buy 20. You will have to recycle the other good casting. Okay. So based on these historical records, okay, you are given the probability distribution. I'll show you later. You need to answer these two questions. How many casting should you schedule to produce so that you can maximize your profit? And what is the probability of losing money at this production level you choose? So let me show you the probability. So how do we read this table? For example, if you schedule to produce 20 casting, okay, the probability that you have 12 good casting out of 20 casting produced in total is 0.05, okay, and so on. Why are these rows, why are these rows zero? So if you schedule to produce 20 casting in total, you cannot have more like 21 good casting. That's not possible. Okay, so I think it's very straightforward and easy to understand this table. Let's take another example. So if you schedule to produce 27 casting, what is the probability that you have 20 good casting? Exactly 20. So here, okay, the probability is 0.05. That's it. It's very straightforward. Okay. Now let's do the math. You need to consider two scenarios. Number one is the number of good casting is less than the number required by the customer. And second, what if they are greater or equal to the number required by customers? Let me show you the formula here again. Okay, so there are two scenarios we need to consider. Firstly, the cost, right? CX. We have two scenario, right? Scenario number one, the number of good casting less than the number required by customer. Remember that the customer require you to produce 20 good casting, okay? So in this case, it's less than 20. And in the second case, it will be 20 here. Okay. So remember, as I mentioned earlier, if you produce less than 20 good casting, they don't buy anything. Okay. So you have to recycle all of them. So here, the equation will be 200 Q. Okay. Why 200? Because it's the recycle value, and this is the number of casting you schedule to produce here. Okay. So for example, if you can only produce 18 good casting, you will have to recycle all of them. The customer won't buy from you. But what if you somehow manage to produce more than equal or more than 20 good casting? They will buy 20, they will buy, sorry. So here, um, oh, forgive me. Oh, no, no, no. My bad. This is not cost. This is revenue. Okay, my bad. So if you manage to produce more than or equal to 20 good casting, they will buy exactly 20 good casting, no more. And the rest, you have to recycle them, okay? So how much are they willing to pay? 2,500 per casting? Okay, so it will be 2,500 multiplied by 20, and the rest of the casting, it will be Q minus 20 um, multiplied by 200, if I'm correct. Okay, that's correct. Now, you have already have the formula for the revenue, right? We move to cost. So it costs you $1,100. Okay, so it will just be $1,100 multiplied by Q. That's it for all of this scenario. Now, let's come to the profit. Do you remember that profit is equal to revenue subtract by cost? Okay, so we only need to subtract these formulas. Again, we have two scenarios. 20, 20. Okay, so the revenue for this scenario will be 200Q minus Q. It will equal to minus 900Q. So yeah, it's very bad for the business. 900Q. How about the below scenario? You take this formula and you subtract by this formula, okay? So finally, you will receive 46,000 minus by this amount. So, okay, now you have all of these equation. What will you do next? So remember, we want to maximize the expected profit. This equation is just the profit, not expected profit. So I believe you remember this, right? The expected profit will equal to the profit multiplied by the probability for each scenario. Then you sum all of them up, okay? So let me show you. The expected profit. We have two scenario, right? So firstly, x less than 20. So we have x from 0, right? Oh yeah, 0. X from 0 to 19 minus 900Q. Then you multiply by px. Yeah. And for x larger than 20, you will have 20 to Q 46,000 minus 900Q and multiply by px, right? Remember to multiply px for each terms, okay? Otherwise, you will be wrong. Okay. So now, let's transform them a little bit. Let me see. So here, because 900 and Q is a constant, so you can pull them out of the summation, okay? And the same thing goes here. Oh, by the way, um, you can just split out this summation. Again, 46,000 here is a constant too, so you can pull it out of the summation. Okay, px minus 900 q x 20 q px. Okay, so now um, there is the same thing here, so we can group them together. 900 q it's 0 19 px x x from 20 plus 46,000 20 q px. Okay, so now here's the fun part, because x runs from 0 to q. So the summation of all of this probability will equal to 1. Okay. About this summation being equal to 1, if you don't understand about this, you can ask me in the comments. I will show you another example. Okay. And here it's the same. X 20 Q P X. Okay, so finally we will have our equations as below. Let me show you. It's a little bit messy. Uh, oh my God. So finally we will have the E, the expected profit to produce Q casting will equal to minus 900 multiplied by Q plus 46,000, and the sum x20 to Q px. So here is our last equation. Okay, I'll copy it here for you to see. Okay, so now we have all of the equations. So what will we do? We will just need to calculate the expected profit. Okay, but now because uh, it involves a lot of calculating and stuff, so I'll use Excel to calculate them. Now here, the probability distribution I showed you before. This table will be given to you in the exam. Okay. Now let's calculate the profit table. So how do we achieve this table? About the formula, I won't explain it here. I'll explain it from um, the equation perspective. Okay, let me copy the profit formula. Okay, so we have two scenario, right? I'll divide the table. I'll divide the table right here. Okay, so if x is less than 20, you will use this equation to achieve this number. Okay, for example, here if you can only, oh my God. Sorry. Where did I stop? Okay. So if x is less than 20, you will use this equation, minus 900 multiplied by q, right? So for example, if you produce 21, q equal to 21, and x is less than 20, then you will take 9 minus 900 multiplied by 21, and you will receive minus 18,900. That's it. It's that simple. Now, what if x is more than 20, which is here? X is more than 20, less than q. You will use this equation. So for example, again, if you produce 21, if q is 21, then the equation will be 46,000 minus 900 multiplied by 21, and you will receive 27,100. That's it. The same for these guys, okay? And again, these cells are zero. The reason I have already explained in the previous part, so I won't re-mention it. So here, now you have the profit table, right? So what do you do next? You want to know the expected profit, right? The expected profit. Um, do you remember when I say that the expected profit will equal to the profit multiplied by the probability for each scenario? You remember that? Yeah. So this is what exactly we will do in this scenario, in this table. This is the expected profit table, and we will use the sum product. What is it? So to put it simply, we multiply each of these things together and sum them up. So for example, for 20 casting, we will sum the probability of producing 12 good casting with the profit, this with this, then this with this, and again and again and again, and we sum them all up, and we receive this number, minus 6,500, okay? And we do the same thing for these guys, okay? And we can see that the maximum profit, expected profit, will be achieved when we produce 28 casting, okay? So this will be the optimum number of casting we should schedule to produce. Yeah. So that was how the Excel calculates the expected profit. Now I'll do it by hand to show you, okay? So where do we have this number? Minus $6,500. So if we want to calculate the expected profit for that scenario, which Q is 20, right? We write here. We just need to plug the number in this equation. Q is 20, 46,000, and the sum of PX, X from 20 to Q. Q here is 22. So you only need to multiply it by P20. Okay, P20. You will have minus 1,800, 46,000 multiplied by Q is 20, and PX is also 20. We look at this probability table. Q is 20, X is 20, which is 0.25, okay? 0.25. Uh, where's my pen? 0.125. And how much you will receive? Minus 6,500. Just like the table in Excel, which has already calculated for you here. Okay. Now, let's do it one more time. I'll calculate the expected profit for Q equal to 23. Okay. Q equal to 23. Twenty-three. Q is 23. So here you will have PX P20 plus P21 plus P22 plus P23. Okay. Trừ 20.746.000. Okay, let's sum all of these up. X equal to 20, 21, 22, 23, and Q equal to 23, right? So let's look again. Let's look at this probability table. We are calculating Q equal to 23, right? And we want to sum from 20 to 23. 20 to 23 right here, okay? What is the sum? The sum is 0.07, 0.7, right? Not 0.07, sorry. Multiply by 0.7. Let me check the result. 11,500. Let us check the example. Yes, 11,500, just like the calculation in Excel. So that's it. Based on our calculation, you will do the same thing for all of these number of casting produced Q, but you can automate it by using Excel because there are a lot of numbers. You can make mistakes along the way, and it's very manual. So don't do it manually, just use Excel. Well, except for when you take a paper exam. Um, so yeah, the optimal number of casting you should schedule to produce will be 28 because this number will maximize the expected profit you will receive. But that only answer the first question. Where is it? The first question. Okay, right here. Okay. So you can answer the first question. You should schedule to produce 28 casting. About the number two, what is the probability of losing money at this production level? What is the probability of losing money? So if you schedule to produce 28 casting, you only lose money. You only lose money when you produce when you don't produce more than equal or more than 20 casting, but the probability is zero, okay, is zero. You will always produce equal or more than 20 good casting. So the probability that you lose money will be zero, okay? So yeah, that is it for this video. This has been a very long video, right? I don't remember. So if you have any question, just ask me in a comment because this is a hard problem. So I may stutter a lot in my video. So if I say anything that is unclear, you can just ask me in the comments below. And if you want me to show you what formula I use in the Excel file, just comment down below. I'll do a video if mm, many people request it. So that's it for this video. Thank you. See you again.